When we think of stars, we probably think of tiny, shiny objects in the night sky. At least, that's how we see them from down here on Earth. But, you see, stars are anything but small. In fact, one of the largest stars, Betelgeuse, happens to be much larger than our Sun. For years, this star has baffled scientists. However, recently, something more unsettling has been happening with Betelgeuse that's making scientists and other well-informed folks very concerned. Join us in this video as we explore the terrifying details about Betelgeuse, its imminent destruction as predicted by the James Webb Telescope, and how this new development will affect our galaxy and our lives right here on Earth. Music. As described by physicist Michio Kaku, Betelgeuse is a cosmic wonder, a giant star that has interested cosmologists for so long. A Greek astronomer named Ptolemy was the first to discover it. This star is so big that it can be seen in the night sky from Earth during winter. If you're into constellations, you've probably seen or heard of this star. It is the reddish-orange star that marks the upper left shoulder of the Orion constellation. So, you see, this star is ancient, and to date, it is one of the brightest stars in the night sky. But one thing about Betelgeuse's brightness is that it doesn't stay constant. Instead, it fluctuates. This fluctuation is one of the unique properties of this star. But it isn't the only one. Let's see some of Betelgeuse's unique properties. Most of the stars you see in the night sky are actually far from Earth. The closest star is 4.2 light-years away from Earth. If you don't understand how the term light-years explains distance, picture it this way. Imagine moving at the speed of light for a whole year. It's been proven that light can cover a distance of 186,000 miles per second. Hence, the distance light can cover in a year is equivalent to 1 light-year. If you do the math, you'll have billions of miles. So, when we say the closest star is 4 light-years away, it means it's billions of miles away from Earth. But guess what? Some stars are even farther, and Betelgeuse is one of them. Betelgeuse is located about 600 light-years away from Earth, so if you were to go to it, traveling at the speed of light, it'd still take 600 years. We can't move that fast. Not even our fastest spacecrafts can. But yet, this star can still shine so brightly in our sky. If you're wondering how Betelgeuse can be so bright despite the distance, that's because of its other qualities like size and brightness. Betelgeuse is about 500 times bigger than our Sun. Its radius is believed to be about 1,000 times that of the Sun. It is so large that it appears as a disk in space when using sophisticated telescopes, whereas other stars appear as little points of light. The disk appearance is suspected to be an effect of the reactions on the outer layers of its atmosphere. In terms of mass, Betelgeuse measures about 12 to 19 solar masses. A solar mass is the standard unit of mass used by astronomers. One solar mass is equivalent to 2 by 10 to the 30th power kg. Scientists cannot determine the exact mass of Betelgeuse because there are no other planetary bodies orbiting around it to compare it with, and of course we can't measure it directly from here on Earth. But it's confirmed that this star is at least 12 times heavier than our Sun. The brightness of Betelgeuse ranges from magnitude +0 to +1.6. In more familiar terms, Betelgeuse is 16,000 times brighter than our Sun. No wonder it was nicknamed the Red Giant. However, the brightness of Betelgeuse doesn't stay constant. It fluctuates. This fluctuation is due to its pulsations. In other words, Betelgeuse expands and contracts. When it expands, it gets brighter, but when it contracts, it dims. This process can occur for 10 to 100 days or even more. One unique property of Betelgeuse is that its surface is covered in dark magnetic spots. The magnetic field in these areas is far more potent than on the regular surface. But the downside is that these strong magnetic spots inhibit the flow of hot gas to the star's outer surface, making the star cooler in these regions. The fact that Betelgeuse has many of these spots compared to our Sun explains why it's cooler than our Sun despite its size and brightness. The Sun also has its own dark magnetic spots, but the ones on Betelgeuse are much larger and very numerous compared to the ones on our Sun. To give you an idea, the spots on Betelgeuse can be twice as large as Earth. Betelgeuse also has a magnetic field that is 1,000 times stronger than that of the Sun. This field is why, when viewed through a telescope, the gases on the surface of Betelgeuse seem to be in loops or arcs. Betelgeuse has a surface temperature of about 3,500 Kelvin. This low temperature contributes to the low energy emitted by this star and its dim red color. Betelgeuse is a red star. However, it wasn't always red. It was yellowish about 2 million years ago, just like our Sun. Over the years, the color started changing to orange-red, and then, about 2,000 years ago, it slowly started becoming the red star we know today. This fact has made scientists believe that the star is getting old. Betelgeuse emits as much as 7,500 times more energy than the Sun. It might have been a fair rival to the Earth's Sun if it weren't so far away and in its prime. The fact that Betelgeuse, which is 600 light-years away, can still be seen and identified with the naked eye at night is quite impressive. Our Sun is only 8.3 light-minutes away from Earth, which is why it is so effective. If Betelgeuse were just slightly closer, we might even be able to see it during the daytime. But if it were to replace the Sun, it would swallow up or displace the Earth and the other 4 planets close to it due to its massive size. Moreover, even if it could fit, it emits more radiation than our Sun. That alone would make it a bad sun for Earth. So, maybe it was never designed to be our Earth Sun, just a distant giant red star that we can admire and study from afar. The red light from Betelgeuse is even more pronounced because of the distance of the star from Earth. One thing about the universe is that it's constantly expanding. This expansion alters the light rays from objects and galaxies so that only longer light wavelengths travel farther. Red light has a longer wavelength than blue light, so at far distances, blue light will not be visible, only red light. But, as fascinating as Betelgeuse has been all these years, one thing remains clear. It is an old star almost nearing the end of its lifespan. You see, stars become red towards the end of their life when the hydrogen in their cores transforms into helium via nuclear fusion. At this point, the star slowly transforms into what space experts call a red giant, and from what we know about stars, heavy stars age faster than light stars. Since Betelgeuse is about 12 times heavier than the Sun, it's dying at an accelerated rate. Also, this star's irregular pulsations and brightness are another strong sign that it's dying. Betelgeuse started dimming in 2019, but the lowest brightness ever recorded of Betelgeuse was in February 2021. This was when concerns about the near-death state of this star began to grow in the science community. But wait a minute, how do stars die? Well, they explode, something scientists call supernovas. So what is a supernova? If you've ever seen a nuclear explosion, just know it's nothing compared to a supernova. A supernova is a massive and powerful explosion that occurs when stars reach the end of their lifespan. An enormous amount of energy is usually released into space whenever a supernova occurs, making supernovas some of the universe's brightest and most spectacular events. However, there are 2 types of supernovas, Type 1 and Type 2. A Type 1 supernova occurs when a remnant of a low-mass star collects matter from a companion star until it reaches a critical mass that it can no longer bear. As a result, it triggers a nuclear reaction, and the star explodes. A Type 2 supernova occurs when high-mass stars like Betelgeuse run out of fuel and can no longer support their own structure. As a result, the star explodes, releasing an enormous amount of energy. A typical Type 2 supernova will release light, heat, and radiation. They can be so powerful that they can wipe out everything in their path. Sometimes, a Type 2 supernova can emit light so bright that it overshadows all the other stars in the galaxy it is located. Type 2 supernova explosions also create heavy elements like iron, nickel, and gold. These metals are formed during the high-pressure and high-temperature reaction, then scattered into space as the star explodes. As they enter space, they get added to the new stars that will emerge from the supernova. Supernovas mostly result in the formation of new stars or planets thanks to the shock waves that accompany the process. So, what kind of supernova are we to expect from Betelgeuse? A Type 2, of course. And this is what Michio Kaku fears. Now, Betelgeuse may blow up sooner than we think. Now, is this good news or bad news? Well, it all depends on how things turn out. The last time a supernova occurred in our galaxy was in 1604. Typically, supernovas are very beautiful and produce beautiful colors too. Despite their beauty, they're not something you'd want to see up close, as they can be quite deadly. What would happen if Betelgeuse's supernova hit Earth? You see, one common trait of supernovas is the high-energy radiation they always emit. A typical supernova will release a burst of gamma energy 1,000 times more powerful than our sun's radiation. Surely you know what severe effects the sun's radiation has caused since global warming became a thing. Well, it'd be 1,000 times worse if a supernova's radiation were to get to Earth. It could destroy our ozone layer, for one. The shock wave alone could be devastating. If it gets to Earth, it can wipe out nearly everything on the surface and make life on the surface very terrible. Several creatures, including humans, would die off and we would face another extinction-level event. Popular belief is that something like this had happened in the past, long before we got here. Scientists and researchers speculate that a mass extinction occurred about 300 million years ago, as some rocks from that time seem to tell that story. Again, a supernova would ruin our atmosphere. Imagine if the sun came so close to Earth. How many things would survive the heat and radiation? Such high-level radiation can alter your DNA, and I don't mean that in a good way. Radiation won't make you transform into the Hulk or give you superpowers. That only happens in the movies. Instead, a typical radiation overdose will melt you from the inside out. So, if Betelgeuse goes kaboom, these possible catastrophes might befall Earth. Some theorists believe humans can only survive such a radiation blast if we run underground and live there. The Earth's crust is the only thing that can absorb such radiation blasts. So, if we can evolve to live underground, we'll be safe. But then, some of the world's scientists and cosmologists believe we don't have to worry about Betelgeuse at all. They say we're safe since Betelgeuse is so far away. But you see, the thing about science and the universe is that we learn new things every day. For instance, the James Webb Telescope recently discovered 6 massive galaxies in space that are just as large as our Milky Way galaxy. Before now, scientists never knew that these galaxies existed. They didn't think galaxies of this size could exist until the James Webb Telescope proved them wrong. And guess what? These galaxies contain just as many stars as our Milky Way. The discovery of these stars made scientists question everything they thought they knew about the universe. And it also leaves us wondering what other information we've been told that may not be entirely true. And so, the belief that we're at a safe distance away from Betelgeuse's supernova may be wrong. We don't know what other superpowers or abilities Betelgeuse has, as we've only been able to study it thanks to the latest inventions like the JWST. So far, Betelgeuse already possesses several unique abilities like the pulsations we talked about earlier. The supernova may surprise us even more. Maximizing their capabilities, the USSR started to build and launch bigger spacecraft that were designed to maintain high altitudes and vast distances. The Soviets were quick to experiment with both manned and unmanned spacecraft. At the same time, the Soviet scientific community was working on a series of calculations and estimations to create accurate trajectories for the Venus missions. In the background, their Mars programs were also running successfully. For the Soviet Space Agency, nothing was more important than developing sophisticated instrumentation for these probes. This translated to the biggest revelation in the history of cosmological studies. In 1966, the Soviet agency launched Venera 3, making it the first artificial probe to enter the atmosphere of Venus and successfully touch the planet's surface. This groundbreaking success had amplified the competition between the two superpowers. As opposed to the American missions that were filled with failures and deadlocks, the Soviet program continued to gain traction. Despite the program's slow burn, the USSR was pulling all the strings to send successful probes into the Venusian atmosphere. The biggest problem with this trajectory was limited design capacity. The Soviets were quick to overcome their design issues and launched the biggest spacecraft of the Venera program in the 1970s. Their high lifting capacity allowed them to conduct the first dual launches of Venera 4 and Venera 5. According to most historians, this was the most interesting decade in the history of cosmological studies. As a matter of fact, the United States of America did try to come up with similar launch designs. So why did the Soviet agency send dual launches into Venus in the first place? You'd have to understand that interplanetary travel requires sophisticated instrumentation that can gather the highest level of data and evidence. Of course, the spacecraft was first sent to monitor the surface of the planet. This is exactly what happened with Venera 4. Since the launch went smoothly and the spacecraft entered the atmosphere of Venus successfully, the Soviet program proceeded with Venera 5. It wasn't just a repetition of the first launch. The second spacecraft was particularly engineered to gather unprecedented data about the planet. In other words, the Soviets were looking to crack the temperature, atmospheric pressure, and level of radiation on Venus. They didn't have to wait too long for their answers, though. By the early 1970s, the Soviet program was entering the most refined phase of the Venera missions. You see, everything the USSR had done until then was about research and development. It was about making sure that their designs and constructions were optimized. It was also about perfecting the techniques and mechanics for interplanetary travel. But for the second decade of Venera missions, the Soviet Union was looking to conduct experimental missions. The most successful and interesting launch of this time was Venera 7. As the 11th Soviet probe entered the atmosphere of Venus, it became the first spacecraft to send data from another planet. The planet's high temperatures, thickness, and surface pressures were already noted. Now, the Soviets were trying to record Venusian sounds for the first time. The next big success for the program came in the early 1980s. Venera 13 had surpassed all previous interplanetary explorations in terms of sophistication. This particular spacecraft was the first to capture colored panoramic photos of Venus's surface. During the same time, the Soviet program launched Venera 14 to gather similar data about the planet's surface. As the Soviet Union was one of the first nations to discover and recognize Venus, the Russian Federal Space Agency has revived its ambitions in the Venerad missions. Venerad is a planned joint mission between Roscosmos and NASA to explore the atmosphere and surface of Venus. The D in Venerad stands for Dolgovechnaya, meaning long-lasting in Russian. The mission is expected to launch in the late 2020s or early 2030s. It aims to study the planet's atmosphere, climate, and geological history and search for signs of life or past habitability. The spacecraft will include an orbiter, a lander, and possibly a balloon to study the planet's atmosphere in detail. Would you like to know more about the Venera missions or the upcoming Venerad mission? The particles from a Betelgeuse explosion could get carried to Earth at speeds faster than light speed, or perhaps the shock wave from its explosion may trigger the spontaneous eruption of another star that's close to us. Capella is only 43 light-years away. If a star like that gets triggered, Earth will definitely suffer from its aftereffects. So, let's say we're safe from the blast and it doesn't get to us. What other effects would we feel from Betelgeuse's explosion? Well, it'll only be light effects. You see, a supernova majorly releases light and energy. So, if Betelgeuse exploded, you'd find its bright light in the sky anywhere you are in the world. Science research has predicted that a blast from a giant star like Betelgeuse can result in a light so bright that it will be seen even in the daytime. It'll just be like seeing a faint red star shining close to the sun in the day. But that's not all. It's also predicted that the resulting aftereffects of Betelgeuse's supernova will shine brighter than the moon. Now, this doesn't mean we will have two moons on Earth. You see, the bright lights from Type 2 supernova blasts don't last forever. At least, they last for 2 weeks and at most a few months. And so, Betelgeuse's supernova may light up the day and night sky for about 2 months or more, after which it'll fade away. What will become of Betelgeuse after it explodes? In the following years after Betelgeuse explodes, it'll leave behind a black hole. When heavy stars explode, they often leave a black hole behind. However, if a black hole doesn't form, what will be left behind will be a diffused patch of faint light. In a few years after that, this leftover light too will fade away. So, the final question is, how soon will Betelgeuse explode? Well, we can't say for sure. Some scientists believe Betelgeuse's supernova may still take 1,000 years to come. But given this star's current level of dimming and pulsations, these groups of scientists may be wrong. The fact that renowned theoretical physicist Michio Kaku raised the alarm shows that Betelgeuse is on the verge of collapse. It might happen within the next 100 years, a decade, or even in a couple of years. After all, in 2019, when it first started dimming, scientists discovered that the top of Betelgeuse physically blew up, releasing a considerable mass of itself into the surrounding space. That may have been the warning sign to prepare us for the incoming supernova, but we don't know for sure. We must keep our fingers crossed. Thanks for watching. If you would like to watch another exciting episode, click on the video thumbnail now showing on your screen. I'll see you there.